So this is just an extension of what we started last week. So let's look at what we did last week. And I want to focus specifically on letter H. We did all of these. They were solving for x. Let's look at this one right here. When we look at this one right here, we go, okay, we boxed it out. We simplified. We got -7 and -1. I'm actually going to approach this problem in a different way. So I wrote down the problem from before, but I'm going to look at it a little bit differently. I want you to look at the x plus 2. Do you see how they both have an x plus 2? So whenever I see x plus 2, I'm going to put x instead. Since they both have it, I'll just call it x. And then I'll write down everything else I don't have. Let me make that x a little bit closer so it looks more like a problem you've seen. Okay, and actually the problem said plus 4x, so okay. So I would magic x this like I would do before. Two numbers that multiply, two numbers that add are 5 and 1. This is bigger, so it's positive. I set it equal to 0, and I get -5, and x equals 1. The problem is, if you look, that's not what I got. I got -7 and -1. Well, that's because here I was solving for x. But here, I didn't actually solve for x. I solved for x plus 2. So technically, I can't write x equals 5. I need to go back now. And I need to write x plus 2 equals -5. And I can't write x equals 1. I have to write x plus 2 equals 1. Solve. Solve. And now, I get the same answer. Now some of you go, can't I just do it this way? Sure, but you have to know we're going to get into more complex problems. So let's actually do that right now. Let me close my tops really quickly, and you will be back on that page. Okay, so that's the homework. All right, so now let's look at this problem right here. So this is very similar. If you look, well, let's look at this one first. They're asking me to solve this one, so I magic X it. Two numbers that multiply, two numbers that add are 4 and 3. Set it equal to 0. X equals -4 and -3. I can handle that. But this time what they're saying is, okay, you have a problem that kind of looks similar, but it's different. So what's one alternative I can do? I can box this out. I could distribute the 7. I could put everything together. I could add 12. And then I could solve. But for me, I would rather simplify it. First of all, there's fractions, so that makes it difficult. I'm going to do this. Whenever I see 1/2 x plus 7, I'm going to call that x. And then everything else I'll keep the same. So plus 7x plus 12 equals 0. Now I magic x it like before. And I get x equals -4 and x equals -3. But the problem is, it isn't that x equals -4, it's 1/2 x plus 7 equals -4. And it isn't x equals -3, it's 1/2 x plus 7 equals -3. So what I like to do is when I look at a problem like this, I don't know about you, but this looks very intimidating. When I get intimidated by things, I like to simplify my life. I like to go to my happy place. X is my happy place. Then once I feel comfort, then I can go back to being fancy. So now I solve this like I normally would. Subtract 7. Subtract 7. When I have a fraction that's being divided, let me get my blue pen to emphasize this even more. If this is divide by 2, the opposite is multiply by 2. Or some of you go, can I just multiply by the reciprocal? Yes, the reciprocal of 1/2 is 2. And so now, this is gone. 1x is just x equals -22. This is gone. 1x is just x. X equals -20. Now, how do you know if I'm right? Okay, I could check it. So let me check the 22. Half of 22 is 11, but it's -11. Plus 7 is -4. Squared is 16. Okay. Half of -22 is -11. Plus 7 is -4. Times 7 is -28. And then plus 12. And 16 plus 12 is 28, minus 28 is 0, so I know I'm good to go, and the other one works also. Okay, so let's see, is there another way to solve it? I think we get the idea, okay? Oh, You could do the quadratic formula, or you could complete the square. But I would tell you that I would not want to complete the square. Yuck. Because if I go x squared plus 7x equals 12, and I've got to take half of 7, it's going to give me a decimal, which I have to turn into a fraction, and yucky, yucky, yucky. Okay? All right. Now let's look at this one. There's one option. I could box this out, so change the signs of everything to the right, put this all together, move the 6 over, set it equal to 0, and solve. But what I would rather do is, when I see all of this, guess what I'm thinking? X. Could I put m? Yes. But I feel safe in my happy place of x. Now everything else stays the same. And now this looks familiar to me. Set it equal to 0 and solve. Two numbers that multiply to get 6 and add to get 1 are 3 and 2. If you're struggling here, this step right here, you need to be asking me questions. If you can't factor, you will cry the rest of the year. Okay? That is definitely my mantra that I say how many times. You need to know how to factor. You need to know how to solve for x. So now I get x equals 3 and x equals negative 2. But is that my answer? No. I'm not saying x equals 2. I'm saying m squared plus 5m minus 24 equals 2. And I'm saying x doesn't equal 3. M squared plus 5m minus 24 equals 3. Then I would set it equal to 0, and I get m squared plus 5m minus 26 equals 0. M squared plus 5m minus 27 equals 0. And then what am I going to have to do? I can't find two numbers that multiply to get 26 and add to 5. I can't find numbers that multiply to get 27 and add to 5, so I would have to quadratic formula, and I'd have to quadratic formula. Now, how many answers would I get here? I would get 2 answers, and because we're out of space, I'm not going to do it. And then I would get 2 more answers here, which means how many answers total am I going to get? There will be 4 solutions because I did the quadratic formula, which means they will be decimals. I'm not going to do it. You know how to do the quadratic formula. And some of you go, 4 solutions? Well, think about it. If you just had m squared, it would be 2 solutions. But if you square a square, that's actually m to the 4th. It makes sense that there are 4 solutions. Okay? All right. So now let's go to 3-7. I don't know about you, but this looks confusing to me. I'm in my happy place if that 3 was not there. So in a sense, what I'm saying is I don't want x to the 1/3 power to be there. And some of you go, what? Well, if I had, let's see if I can get a pen here and explain it. If I have x to the 2/3, I bet you would agree it's not difficult if the 3 is gone, right? If it's just a 2. Well, what if this instance the 2 is gone and there's just a 3? That would be x to the 1/3. 1/3 times 2, 2/3. So what I'm saying, let me go back here, is that when I see 2/3, I'm thinking that's really x to the 1/3. But we'll worry about that later. I'd like to be in my happy place by going an x here and an x here. Look how I can simplify this now. Reminds me of factoring. Okay. And some of you go, how do you know if I can factor? Well, that's what I'm doing. I'm presenting problems that you can factor. 2 numbers that multiply to get 56 and add to get -1 are 8 and 7. This is bigger, negative, positive equals 0. Then x equals -7 and x equals 8. But does x equal -7 or does x to the 1/3 equal 7? So now I have to rewrite this as x to the 1/3 equals 7. X to the 1/3 equals 8. Now some of you go, wow, this is really hard. I know this is actually called factoring complex equations. And complex means it's difficult. But if you're really good at the simple stuff, and I'm not saying if you can't do this, you're not smart. I said simple compared to complex. Okay? Then this will be easier. Okay? If you can simplify your life when it's really crazy, it just means your life could be easier. You know, you see those people that freak out over one little thing. It's because it's so complex to them, they don't know how to simplify it. All right. Now, how do I solve this? If this is to the 1/3, if I cube it, then this cancels. X to the first is just X. And 8 cubed, I don't remember what 8 cubed is. 512. And then 7 cubed is 343. And some of you go, how the heck do I check it? Well, you could take 343. Let me do it because I can't help myself. I'll check one of them. Okay? So I have X to the 2/3. And some of you go, I don't care if I check it or not. Okay. Well, then don't care. Then just space out right now. But I don't know about you. I'd like to know if I was correct or not. I don't want to have to cheat to find out if I'm correct. I don't want to cross my fingers to know I'm correct. I want to make sure I know I'm correct. So what I'm going to do is I'm going to plug in 343. So I'm going to go 343 to the 2/3 minus 243 to the 1/3 minus 56 equals 0. And some of you go, well, that doesn't look like you made it easier. No, I didn't say I did yet. But I know 343 is 7 cubed. Oh, that pen is awesome. Is 7 cubed. And if I take that to the 2/3, that's 7 squared, which is 49. Minus, minus. This is 7 cubed to the 1/3, gone. 7 to the first is 7. Okay. And then minus 56 equals 0. Okay. So then I made a mistake somewhere. So let me pause it and figure out what my issue is. What I love about making mistakes is some of you go, well, it doesn't equal 0, so it's no solution. No, does anybody see? Hopefully some of you saw my mistake. My x didn't equal 7. What did my x equal? -7. So if I cube -7, that's -343. So let's come back here, and that should be negative, and that should be negative. So now let's go back. So -7 squared is 49. -7 to the first is -7, and a negative make a positive. Now 56 minus 56 does equal 0, and I'm right. Okay? I love when I make mistakes because it reminds you that just because you make a mistake doesn't mean the answer is no solution. It could be, but it could also mean you made a mistake. All right. So I look at this problem here. Let me zoom it in. And I go, oh my gosh, I can't even see that. I'm probably going to have to get my glasses on. I can't tell if it's y to the 6th or y to the 8th. I think it's y to the 6th. Yep. All right. So when I see y to the 6th, I go, oh my gosh, that does not seem easy for me. So I'm just going to call that y squared plus 3y minus 18 equals 0. I don't know if a lot of you are noticing. I just go back to my quadratic place. Okay. Now we'll worry about how to get back there in a little bit. Okay. So two numbers that multiply to get 18 and add to get, oops, I'm using y. Could I use x? Yeah. I'm using y this time to change it up. Two numbers that multiply to get 16 and add to get 3 are 6 and 3. This is positive, so that's positive. Y equals -6 and y equals 3. Now, what I want you to see in this problem, shoot, one sec, is that if you had y squared, how could I make it go to y to the 6th? Well, I could cube it, couldn't I? So if I cube it based on exponent rules, I would get y to the 6th. So what does that mean I could do? I can actually cube it. And then I'm good to go. Now, I actually would have approached this problem differently. What I would have done is this. I would have gone, and do whatever you want because I'm teaching you this way, but I want you to see a variety. When I would have gotten to y plus 6, y minus 3, I would have gone like this right away. Because I know that y cubed and y cubed is y to the 6th. I know, sorry, my dog, 6y cubed minus 3y cubed is 3y cubed, and 6 times 3 is 18. If you don't know what I'm talking about, you'll just throw back the y cubed. Okay? So let me highlight this. There's a fire truck, so my dog's freaking out, sorry. Now, how do I get rid of to the 3rd power? There's two ways I can do it. I can cube root it, or